All right, in this video, we're continuing our work with radical equations. So let's look at example A here. We have radicals on the left-hand side of the equation. We actually have two of them. So we're going to have to isolate one of the radicals, square both sides of the equation to try to eliminate that isolated radical. And then we'll probably need to repeat it since we'll have a second radical to deal with at the end of that process. I'm going to isolate the radical furthest to the left here because it's slightly more complicated than the one on the right. So let's write it as a square root of 2x minus 1 is equal to 1. And I'm going to move this guy over here to make it a plus square root of x minus 1 on the right hand side. Now from there I'll square both sides of the equation. And when I do that, what's going to happen is the radical on the left here will cancel out, just giving me 2x minus 1, and that'll be equal to, and I'm going to actually have to expand that out. So I'll write it as 1 plus the square root of x minus 1 times 1 plus the square root of x minus 1. Now let's go ahead and FOIL that. It's a good idea here to work a little faster by kind of using the shortcut approach. And the way you would do the shortcut approach is, remember, you square the first number in the binomial. So 1 times 1 gives you 1. And then you square the second piece, right? So the square root of x minus 1 squared is just going to give you what's inside the radical. So in other words, plus x minus 1. And then you have to write twice the product of the two terms, right? So it'll be plus 2 square roots of x minus 1. It's the same result you would get if you FOILed it out in the long way. We're just speeding things up a little bit by using this kind of shortcut memorized pattern. All right, from there, we'll have 2x minus 1 on the left again, and we can cancel out some things here on the right. So we drop the 1 and the negative 1, and we end up having this x here that's next to this radical. Well, we want to remove the x to the other side so that we have the radical on the right-hand side isolated. So I'm going to have 2x minus 1 minus x is equal to just 2 times the square root of x minus 1. Now, from there, 2x minus x on the left-hand side is just going to give you x minus 1 is equal to 2 times the square root of x minus 1. All right, let's square both sides of the equation again because we want to get rid of the radical that's on the right-hand side. So I square what's on the left there, and I'm going to end up with x minus 1 times x minus 1 is equal to 4 times x minus 1. Because the radical is removed by the squaring process. All right, and if we FOIL x minus 1 times x minus 1, we'll get x squared minus 2x plus 1, again using that memorized pattern. If we distribute the 4 into the parentheses here, we'll have 4x minus 4. And then we simply have a quadratic which we can set equal to 0 and solve. So I'll have x squared. If I subtract 4x from both sides of the equation and add 4 to both sides of the equation, I'll bring the minus 4x over and the plus 4 over as well. And we're going to end up with negative 6x plus 5 is equal to 0. Okay, so this is the quadratic we need to solve then. Let's see if it will factor. Do we have factors of 5 that will add to give you negative 6? Sure, I think we can find those, right? So let's use two parentheses here. So it'll be x and x. Remember, if it's a positive on the right, it's 2 of whatever sign is on the left. In this case, it'll be 2 negatives. And when you're looking for factors of 5 that add to 6, I think 1 and 5 will do that, right? And so that's the proper factoring of the equation. And the last step then is to use the zero factor property, which says, look, if these two things are multiplied and the result is 0, it means either x minus 1 is 0 or x minus 5 is 0. So we can see that the solution is x equals 1 or x is equal to 5. All right, so there's our two solutions for the equation above, but remember we must always check to see if they work, because we know that the process of squaring both sides of the equation can introduce solutions that don't work in the original equation. Okay, so let's see if x equals 1 actually does work in the original equation. Well, it'll be 2 times 1 minus 1 under the square root minus the square root of 1 minus 1. Does that in fact equal to 1? Well, 2 times 1 minus 1 is just 1 under the square root, and then minus 0. Is that equal to 1? It is. So 1 actually works in the equation. Let's check to see if 5 is a solution now. So I have the square root of 2 times 5 minus 1 minus the square root of 5 minus 1 is equal to 1. Well, 2 times 5 is 10. 10 minus 1 is 9, so the square root of 9. And that's minus the square root of 4. Does that equal to 1? Well, square root of 9 is 3. Square root of 4 is 2. It will indeed give us 1. So we can say that that checks out as well. So it looks like both x equals 1 and 5 are solutions to the equation. All right, so let's look at example B. So we have the third root of 2x plus 1 is equal to negative 3. The reason why I said the third root is because you know that 1/3 is a rational exponent, which means you can swing around this 3 and make it the index of a radical. So this is exactly the same as saying the third root of 2x plus 1 to the 1 power is equal to negative 3. So you can see that all we have to do to get rid of that exponent is to raise it to the third power. And whenever you do the left-hand side, you have to do the right-hand side. So we're just going to say 2x plus 1 to the 1/3 power is equal to negative 3. And we're going to raise the left-hand side to the third power as well as the right-hand side. And then, of course, when you raise 1/3 to the third power, that just cancels out, giving you 2x plus 1 is equal to negative 3 times negative 3 times negative 3. Well, that'll end up giving you negative 27, right? Because there'll be 3 negative signs. The answer will be negative, and 3 to the third power is 27. All right, from there you just solve this simple linear equation by subtracting 1 from both sides. And you end up with 2x is equal to negative 28. And then you divide both sides by 2. And you'll end up with the answer x is equal to negative 14. All right, so we should check our answer always to make sure it does indeed work in the original problem. So is it true that 2 times negative 14 plus 1 is equal to negative 3? Well, 2 times negative 14 is negative 28, right? Then we'll add 1 to that. And that, of course, will make negative 27 to the 1/3 power. Is that the same as negative 3? So the third root of negative 27 is indeed negative 3. So our answer checks. All right, let's finish this video up by looking at example C here. Example C has rational exponents again, but this time they have a slightly more complicated construction. That's no big deal. Remember, there's still radicals, and the rule is that we isolate the radicals first and then raise both sides to a power to remove the radicals. So I can write it as x to the 3/4 power is equal to 2x to the 1/4 power, because I basically just moved this term to the right-hand side, changing its sign as it went. And then from there, if I raised both sides to the 4th power, what would end up happening is that I'd lose those denominators, right? So here I would end up with x to the 3/4 times 4 over 1 power, and those 4's would cancel out, giving you basically x to the 3rd, right? And that would be equal to, here the 4 would apply both to the 2 and to the 1/4. So again, it would be 2 to the 4th and then x to the 1/4 times 4 over 1 power. Well, the 1 and the 4 here would cancel out, just giving you x, right? And 2 to the 4th gives you 16, so we'd end up with 16x after all of that. Then from there, we'd recognize we have a polynomial here that has a 3rd degree. So we might try to bring everything to one side and then factor and solve. So we'll have x to the 3rd minus 16x is equal to 0. And we say, okay, I can factor out a greatest common factor of x here, leaving me x squared minus 16 is equal to 0. And that's nice because then we have the zero factor property, which says that that must imply that x is equal to 0, or that x squared minus 16 is equal to 0. So the first one is already solved. And for the second one, I can just say that x squared is equal to 16. And then taking the square root of both sides, I'll have x is equal to plus or minus the square root of 16. So our final answer will be x is equal to plus or minus 4. So 3 solutions then. We should check these to make sure they work. So let's do that over here. We'll say, first of all, does 0 to the 3/4 power minus 2 times 0 to the 1/4 power indeed equal to 0? And I think it does, because of course this is just 0, this product will be 0, we end up with 0 equals 0. So 0 checks, so we can say that's a solution. How about 4 and negative 4? Okay, let's go ahead and check to see if positive 4 works. Well, we'd have 4 to the 3/4 power minus 2 times 4 to the 1/4 power. Does that equal to 0? Well, if we take 4 to the 3rd and then take the 4th root of it, and notice we bring the 4 around, we'll have 4 as the index of the radical, and then we'll have 4 to the 3rd, which is 64. And we'll have minus 2 times 4 to the 1/4 power, in other words, the 4th root of 4. does that in fact equal to 0? Well, you can certainly write 64 as what? 4 times 16, right? So the fourth root of 4 times 16 minus 2 times the fourth root of 4. And then, 16 can come out as a 2 because it's 2 to the fourth power that gives you 16. So we'll end up having 2 times the fourth root of 4 minus 2 times the fourth root of 4. And of course, that does indeed give you 0. All right, one last one to check. Let's see if the same thing works out for -4. All right, so we're going to try to see if -4 raised to the 3/4 power minus 2 times -4 raised to the 1/4 power does indeed give you 0. All right, so the problem with this, though, is that if you bring this 4 around and make it the index, you're going to end up having the fourth root of -4 to the third power, which is going to give you the fourth root of -64. And the problem with that is, of course, that there's no real number that you're going to raise to the fourth power and end up having a negative answer for. So with that in mind, we can say that -4 will not produce a real solution to the equation. So we'll just change our answer here to just x is equal to +4 because the -4 doesn't check out. So it has two solutions, x equals 0 and x equals 4.